Hello and welcome. I'm Adam, the Push the Envelope, the channel that gives you everything artificial intelligence and machine learning. This week we're going to be looking at how do we predict the stock market using tweets. Now, for some, tweets may seem like an odd choice to use for predicting the stock market, but it's actually a fairly good indicator of which way the stock market may or may not be moving. So what we're going to be doing is taking tweets, let's say from Apple, and converting those tweets into whether or not they are positive, neutral, or negative. And we do this through something called sentiment analysis. And if we can take that sentiment over an entire collection of tweets, let's say for a day or for a week, we may be able to determine what the stock is going to do in the coming days or weeks. So without further ado, let's go ahead and start building a pipeline to try to convert tweets into that sentiment and then use it to make our actual predictions on the stock market. All right, we are over in our Jupyter notebook, and as you can see, the first thing I have here is a URL. Now, we're going to be using a data set that is actually on Kaggle, so if you follow this link, I'll also throw it in the description. It will take you over to this page, and someone has nicely put together this data set of stock tweets and has labeled them positive and negative for us already. So we're going to take advantage of that to train some of our models here. So go ahead, log into Kaggle. If you don't have an account already, it's free, and just download this data set and we can get started. When you download it, it's obviously going to be a zip file. You're going to unzip it, and then there's going to be a whole bunch of other zip files within it. I have extracted all of the data. If I open my panel here, you can see I put it in something called train. And under train, don't worry about this cleaned one. You should have this stockdata.csv. So if you want to follow exactly what I'm doing, go ahead and throw it in a folder called train. But without further ado, let's go ahead and start coding some of this. So the first thing we need to do is, let me close this side a little bit. We just need to import OS and import pandas. And go ahead and run that cell. And once we do that, we can start actually importing our data. So I'm going to call this data. So data is going to be equal to pd.read.csv train. That's the folder I put it in, and then it is called stock_data.csv. Once you have that, you can display it to the screen just to make sure it imported correctly, and there we go. You can see it's all there, ready for us to go ahead and get started. So let me, instead of displaying data, let me say for line in data at text, print line. And I'm actually going to say dot values here. And this is just going to print all of the individual tweets right here. One more thing, I'm just going to print /n just to keep them spaced out a little bit more. But as you can see, we have a whole bunch of tweets, and now tweets are unique because it's a lot of shorthand, a lot of abbreviations, a lot of punctuation or emojis or any other sort of thing in here. So in order for us to start reading some of this, we're going to have to do a lot of pre-processing to these tweets. And that is the first step, and is probably going to be the step that takes the longest amount of time, is pre-processing the tweets to remove all of the punctuation and get it into a usable form for natural language processing. So we're going to go just step through some of these. We'll probably start looking at some of the punctuation first. So one thing I can do is say, up here in our for statement, I'm going to say for data.locate data at text. I'm going to get rid of this dot values for a second. I want to know when dot text dot str, this is for strings, so it's going to take all of the strings within there. And I want to know when it contains, so dot contains. I'm going to just call this look_for. I'll define that in a second. I'm going to say regex equals false. Okay, and then we got to finish our square bracket there, dot values, and I'll explain what this is. So what this is going to do is it's going to go through the lines and it's going to look for any string, so any line that contains a certain symbol, a certain phrase, anything like that. So up here we can define look for to be equal to, let's look at some of these. How about this hyphen that's separated here? Or actually, let's go with the apostrophe. So let's look for, I need to use a quote mark here because it's an apostrophe. So this is going to return any line that has an apostrophe. Go ahead and run that. And you can see each of these have an apostrophe somewhere in the tweet. So the only thing we need to be careful of is if I just go ahead and remove the apostrophe, I want to make sure that I'm not accidentally breaking something else. So if an apostrophe is used somewhere else, I don't think there is. A lot of these are pretty standard. So what we're going to do is we're just going to go ahead and get rid of it. So in order to do that, we can use the replace function. So I'm going to say data at text. Let me get my cursor out of the way. Equals data at text. And now we're going to say dot string dot replace. The thing to replace in this case is going to be the apostrophe. And I'm going to replace that, so comma, with just nothing, a blank space there. So I'm going to replace that with nothing, and then I'm going to say regex equals false. We'll get into what regular expression is when we use it, but for now, for this one, we don't have to worry about it, so we can just set it to false. If I run that again, we shouldn't get any because we replaced all of them. And now we can just keep running through that to try to find a whole bunch of other ones. For instance, another one that likely will be out there is a colon. So as you can see, user colon and then a whole bunch of stuff. The only thing that we may need to be careful of is if we have a date, which looking through, I haven't seen it yet. There we go. So we do have a date. So we want to be careful not to just go ahead and remove it. What we may want to look for instead is a colon followed by a space. And that's going to be all of these headers, if you will, the titles for whatever they're trying to do. So that's another one we can replace. So if I copy this one that we just did for the apostrophe, I can replace the apostrophe with a colon followed by a space, and then replace that. I'm going to replace it with just a blank space. So instead of nothing, I'm going to replace it with a space, just in case. I don't want to mess up the spacing of the sentence and then cram two words next to each other. So if I go ahead and run that, we don't have any more. Some other symbols that I can look for, maybe a comma followed by a space. I did a double space here. Again, some people use proper punctuation, so a comma followed by a space appears to be only after words. And it is. So let's go ahead and do the same thing. And replace the colon with a comma. You can go ahead and get rid of all of those. Now, the comma is a good one to go over what we need to do next. So if I just look for a comma, this one just, they happen to not use a space, so we can fix that. But I'm looking for something like this. So a comma in this case is the thousand space. So in this case, we don't want to replace it with a space. We actually want to get rid of it and just combine the entire number together. But if I do that for all of the commas, then something like the one up here now would smush these two words together. So here's where we're going to start using regular expressions. So if I say data at text equals data at text, we're going to do a dot string dot replace. So same thing as before, but what's going to change is what we put in these quotation marks. So let's go ahead and fix all of the instances where there is a comma in between two numbers. What I want to do is I want to look for any number, so any number 0 to 9, To do that, I can use a square bracket, 0 and then -9. After this would be a comma, and then followed by another number 0 to 9. So again, this is anything in the bracket means if anything falls within 0 to 9, including 0 and 9 in this case, followed by a comma, followed by another 0 to 9, then we're going to do something with it. And in this case, we just want to pass in an empty space, a blank, nothing into it. Now, I talked about the regex before. This is a situation where we're using regular expressions. So this is going to be regex equals true. Now, if I run this, one thing I can do is if I want to look at a specific, let me find one here. Okay, this is a good example because there's two in here. If I want to find this specific sentence again, I'm just going to copy some of the sentence, and I'm going to pass that in as the thing to look for, and I'm going to run it. Okay. Oh, I see what I did wrong now. Okay. Yes, so this is taking the entire expression. So it's taking the number, comma, number, and replacing it with nothing. We actually want to keep the two numbers. So instead of string.replace, we're just going to use a dot replace. You pass in an R before this one. Okay, so now this is again using regular expression, but what we're going to do is we're going to reference, I put an R in front of this one. We're going to reference the position of those numbers. So /1 is going to give us the position of this first one right here if I put it in parentheses. So anything in parentheses is going to reference the position. So this is still going to look for a number, but it's going to pass that number into /1 as the position. And now, since I'm trying to just get rid of the space altogether, I can do a /2, but I have to make sure that I put this other 0 through 9 in parentheses. Regular expressions is kind of hard to get used to at first. It's a whole language on its own and takes a second, but once you kind of understand the general patterns, it does get a lot easier. But once again, anything that you, in this case, anything that you put in parentheses will be a position. In this case, it's looking for a 0 to 9 as that position, followed by a comma, followed by yet another position of 0 to 9. Let's go ahead and run that. Okay, there we go. Now we see that our number is it is put together. So all four are together. There's no comma separating the two. I can go ahead and copy this. And I'm going to do the same thing for those cases where it's a letter followed by a comma followed by another letter. So instead of 0 to 9, I obviously can do A to Z. Now, if I was looking for capital and lowercase, I could do an additional thing in here where I'm looking for all lowercase values and all uppercase values. I'm actually going to disregard the uppercase values, and way up here at the top, I am just going to convert the whole list to lowercase. So I'm going to say data at text is equal to data at text dot string dot lower. This is going to, again, make the entire string lowercase so that we don't have to deal with it. If we look back down here, what we have done is we are looking for a letter followed by a comma followed by another letter. The only thing that needs to change is instead of putting the two letters right next to each other like we have here with the /1/2, we need to put a space in between the two in order to make sure that those two words are preserved and are kept separately. And we can go ahead and run that one as well. I didn't have a good example of that one. I could comment this line out. The thing I want to look for again is a comma. And this first one has one in it. So I'm just going to copy a little bit of that sentence. I'm going to look for that. Now when I uncomment this, you see that the comma is not there and our words are separated now. Okay. That takes care of a lot of the commas, but I'm sure there's still a lot out there. There are. So for instance, we have words followed by a comma followed by a period. In that case, we probably also have words followed by a comma followed by a number. So if I go back up here to our regular expression, copy that one down. I'm looking for a word followed by no longer another letter. We're looking instead for a value that's a digit or a value that's a period. Now, in order to do a period, you need to do a backslash with a dot, just because a dot has a different meaning within regular expressions. So this whole thing right here will be a period. Now, when we see that, we just want to put a space in between the two. So if I take this sentence, run it, you can see we now have a space between the dots and between the word. Okay. While I have this one up, we can also see another problem where we have a ton of periods all one after another instead of an individual one. So we can actually go ahead and just look for that as well. If I copy this, I'm actually going to go up here to the string.replace line. I'm going to paste it down here. So we are going to be replacing I'm going to put brackets. I'm going to do a backslash dot. So like we had before where this was looking for a 0 to 9 or a letter, now it's looking for a backslash dot, which is a period. And if I follow that by a plus, that means as many periods in a row as we can find. Now, I don't want to get rid of all the periods because, for instance, if I have a decimal in here, then it's going to get rid of that period as well. So I want to say anytime there are more than one period right after another. To do that in regular expression, you need to use the squiggly bracket. Now, if I want to say 2 or more, I can do 2 and then followed by a comma. This means I have to have a minimum of 2, but I can have as many following that as possible. When I see that, I'm going to replace it with a space, and I want to make sure my regular expressions is set to true. Now, when I run that, I do have an error. One thing I don't need is that plus. The plus just means go on forever, but I actually wanted to set it to the squiggly bracket, so it's just the slash dot followed by the bracket. Now you can see we no longer have those spaces, those dots where we should have a space. Okay, continuing on with this sentence, I'll just kind of stick with this one since there's a lot in it already. But what I can look for is something like the percent sign right here. So I'm going to take one of these that I have up top. I'm going to replace the percent sign, any percent sign, and I'm going to replace it with percent, but I'm going to put spaces on the outsides of it just in case we have an instance like this one where I don't want percent right up against the number. There could be another case where percent is starting it as well. So if I run that one, you can see down here, we had a percent sign, but now it's just replaced by the word percent. Now, don't worry about instances like right here where we have 2 spaces. We can actually just quickly get rid of those as well. So what we could do is sort of like we did for the period. We could say data at text is going to be equal to data at text. And we're going to do a dot string dot replace. And I'm going to say do a space and then a plus. Now remember up top I said we didn't need the plus right here because I was setting what the lower bounds was. If I don't have a lower bounds, then I'm just going to put the plus sign right here. So this is just going to look for any cases of a single space or more. I can end that quote mark, and now I'm going to replace that with just a single space. So if there is 5 spaces that come back with this, it's just going to replace it with a single space. If there's only 1 space, it's going to replace it with a single space. So everything is going to be back to how it should be, and this is going to be using a regular expression. Again, regular expression and non-regular expression is when we have something like this, where the plus doesn't mean a plus sign, or the squiggly brackets don't really mean a squiggly bracket. It's the regular expression notation versus like up here, where we're actually looking for a colon followed by a space. Nothing else in there. No other patterns that we're trying to match. Now if I run this, our sentences are down to a single space in between those. So that's what we want. Now another problem I can see is we have a space at the very end of the sentence. So that can be taken care of another way. So we can say, I'm just going to copy the data equals data part. I'm going to say string, and I'm going to say strip. Now strip is going to take any white space on the front or the back of the string. Does not have to be a white space. It can be a whole bunch of different values. So for instance, if I actually get rid of this for a second, I'm going to put it under the last one we did. But say I want to look for any sort of punctuation at the beginning or end. So I can do some quote marks here. I can say I'm looking for a space. I am looking for a period. I'm looking for question mark, exclamation mark, possibly a comma, and I guess I can just throw in a whole bunch of other stuff too. So maybe parentheses, maybe it's followed by a colon, semicolon. There's a whole bunch of other stuff, maybe a hyphen. I'm just going to stop there. But if I run this, now you can see we no longer have the space. And if I had, like in this case right here, I had a end parenthesis, it is no longer there as well. Parentheses are something easy we can take care of again as well. If I copy that first sentence down, if I look for a parenthesis, then we can just replace it with nothing. Or in this case, maybe let's replace it with a white space. Just because the more white spaces we add, that's easy. We can just take care of it with that last line that we did. It's better to be on the safe side with adding too many white spaces than not having a space in between two values. I'm going to copy that, and I'm going to do the closing parenthesis. Okay, and there we can see now our sentence is starting to look like written language. So we're getting better. These sentences are pretty good. We can look for some other stuff. So as you can see, there is just a ton of this that you need to go through. This is only a handful of the tweets that we're going to see. So there's a lot of pre-processing to these tweets that you need to do in order to get them ready. And it's pretty painful when you're trying to go line by line, finding all of these different cases. Something else that's common in tweets are a lot of the emojis and stuff like that people can make. So if I just look for up here, just a simple smiley face. Actually, I don't see any because we got rid of the parenthesis here. Let me just comment out that line so you can see. Okay, we can see there's a smiley face right there, and then a lot of these other ones as well. So we need to take care of that. In order to take care of it, let's do it before we accidentally remove the parentheses. Again, ordering is also super important in this, like this example. I'm glad that I accidentally did that because it will happen a lot where you're trying to fix something, but something else has already replaced what you're trying to look for. So I'm going to copy what we did down here, and I'm going to be looking for a smiley face. We'll just replace that with a simple space, and I'm going to copy this a couple more times. There's likely sad faces. Maybe there's a smiley face with a nose. There's a whole bunch of different ways that could be on there. I know another common one is 0_O. I saw a couple of those when I was doing this earlier. So, and maybe one more. Maybe we do the winking face. I don't know. So that's just going to take care of all of those. I reran the cell and there's no longer any with smiley faces. So again, it's just going line by line, trying to figure out what all of these things have. If you want to print all of the lines, just go ahead and replace this with nothing. And now we can start to see what are some of the different things that are in here. So if I'm going through it, okay, we have an abbreviation for, called prev. So if I look up prev, okay, you can see here's that post we were looking at before. This is the tweet. It has prev. However, there are other cases where there's previous spelled out. So now when you're replacing prev to be previous, you don't want to accidentally replace this prev with previous, because now you have previousness. So again, one more thing that you need to look for. So if I do I'll just copy one of these string replace down here. I'm going to be looking for prev, but again, I don't want to replace when it looks like previous. So if I follow prev with a space, now it's going to try to match any time that prev is followed by a space, like this one right here. If that's the case, I can just replace it with previous. And make sure you add that space, or else you're going to be cramming letters together. In order to, let me run this. Okay, now our prev has been changed. And you can see that one has been taken care of. Now that post looks fairly good. There's a lot of ticker symbols in there. Let's move on to the next one. Okay, now we have a space hyphen space. So let me look for all instances of that. Okay, a lot of them are just separating thoughts. I don't believe there are any that are like a negative number or anything like that. Again, super important to make sure that you aren't just replacing every hyphen, because there are negative numbers that you could be looking at. So I already have the string dot replaced down here, so I'm just going to look for a space hyphen space, and I'm just going to replace that with a blank space. Okay. There are other instances of hyphens, so let's go ahead and put that in the look for. There is a letter hyphen letter. That just means we need to put a space in between the two. There are, let me see, there are possibly other ones like this one where it means a negative. So we can do our regular expressions to try to find those as well. So like we have up here, maybe I'm just going to copy these two, because we're going to basically be doing the same. So this was when we had the comma in between the numbers and the comma in between the letters. Right after this one, I'm going to say if there's a hyphen in between the numbers or there's a hyphen in between the letters. Now when I'm doing it like this, if there's a hyphen in between the numbers, that probably means it needs to be a 2. So 10 to 12 or whatever. So in here, in between our two positions, our position 1 and position 2, I'm just going to put a space 2 space. For our letters, I'm just going to separate the letters by a space. Now when I run that, that will take care of it, and we no longer have that problem. Okay. While we are working on the hyphen, I guess we can, I'm going to paste one more line down here. I'm going to take care of that negative symbol. So instead of, sorry, let me get rid of this one. I'm going to start over. So down here, grab a string dot replace. So grab this one right here. So we're going to look for we can delete everything in these quotes right here. We're going to look for a negative sign. Actually, we're going to look for a space negative sign. This will mean it's a negative number. So we're going to look for a 0 to 9 after it. So a space negative number. We're going to replace that And I did. So we do need the one before it because I don't want to accidentally replace the number. So yep, let's get rid of this one. Let's copy this regular replace up here. So this is where we have the number hyphen number. Paste that down here. We're going to get rid of the first number and replace it with a space. Okay, sorry. So this is going to be a space hyphen followed by a number. We're going to take, we don't no longer have the second position, so we can delete everything except for one. We're going to say it's going to be a space. We're going to spell out negative and then do another space. So what this is going to do is it's going to replace the hyphen with a space negative followed by whatever that number actually is. To show you how that works, okay, let's look at this 20 million right here. We just copy a part of this sentence. Go ahead and run it. Okay, so if you remember, we had negative 20 million. Now it's actually spelled out negative 20 million. Some of the things I'm seeing right now is million is pushed right up against 20 in both of these cases right here. So we could look for that as well. Doing what we just did before, if I copy this, I'm going to be looking for a number followed by million. And what I'm going to do is I'm going to take the position, I'm going to put a space, and then put a million. And if I run that, you can see our million was separated from the 2 and from the 20. So again, this is a lot of processing that we need to do. I'm actually going to stop right here. I won't painfully go through all of the different things that you have to do. I actually have a GitHub open for what I have put together as a Python script to do this pre-processing for you. I have a whole bunch of rules in it that I took a few hours to try to get these down as best I could to actual written language. So what I can do is go over to the GitHub page. I'm going to copy the link and I'm just going to throw it in here. Okay, so this is the link to the GitHub page. I'm also going to put this in the description along with where you can download the data to begin with. But if you want to jump over to it, there's all the notebooks that I have for this entire series, but right here, preprocessing.py. And you can see lots and lots of regex and regular rules in order to clean this data. So I hope that helps you. We will pick this up in the next video. I'll show you how to use that script, and we will begin actually looking at how do we classify the sentiment after we have cleaned all of our tweets. So I'll see you in the next video. Thanks for joining, and until next time.